is I'll try to put the district around Sukari into this, and Roger can contradict me if I'm wrong. So, because I know really little about it other than I read on the websites and so on. So we look at most normal seas. The exceptions are where we've got reworked Precambrian craton margins, such as that I've been working on in Tanzania, and where we've got major zones of lithosphere thinning, like we have in China. So this is the normal scenario that would be for the Arabian-Nubian shield here. So the first commandment would be about source. So what we want is widespread gold geochemical anomalism. Gold is almost everywhere, and we need to locate the focus points. Well, just in my regional tectonic compilation for the Arabian-Nubian shield, it's obvious that wherever you've got basement, where you haven't got these sandstone and limestone cover, everywhere there's bedrock, everywhere there's near Proterozoic bedrock, you've got gold anomalies. So little gold dots all over the maps where people have recorded small mines or ancient workings and so on. So if we looked at Western Australia, we can see the mines here, but just in that belt alone, as I said before, there are 4,000 prospector diggings that produced something through to mines. So the gold is everywhere. It's just that the gold anomalism is everywhere in the terrain. We've just got to find the focus points where it's coming out. It's a good map that shows these sort of distributions. There's two fairly close together there. You see that's 200 kilometres, so even that's about 30 kilometres apart, 40 kilometres apart, 40 kilometres apart down in here. That's the sort of minimum spacing that we see in the terrain. The second thing, so if we look at Egypt, or we look at Sukari, it works. There's gold anomalism all round. It's just that the big deposit is in one place. We've got dominantly low strain belts with restricted high strain shear zones. They're not schist belts. Well, from what I've seen of Egyptian geology, that's exactly what you've got. You've got very good basaltic textures and so on in most of the terrain, and then you've got high strain shear zones, which you can see on the aeromagnetic data. You can see these things as dislocations on aeromagnetic data, and then around them you've got some gold, and all the little individual gold deposits will be sitting somewhere around these big structures. So as I said, this is just a metre across or something, but imagine it's 20 kilometres. So here's the normal greenstone belt, and here's the shear zone, and it's a very small part of the volume. Space shear zones with lots of, well, so again, you tick the eastern desert at those ticks. We want volcano-sedimentary sequences with volcanic rocks below sedimentary sequences, and if we've got conglomerates, that's a bonus, because these tell us that the terrain was being uplifted during deformation, so the pressure is dropping as it goes up. It's easier for these fluids to boil like the Coke can. The pressure is lower, the Coke can will boil earlier. Like water, go up a mountain, pressure drops, the water boils at a lower temperature. Same thing here. If you can get uplift, the conglomerates are telling you you've got these in your belt. So it's a very good, a good sign. I don't know about the anticlinal hinges and so on, because I don't know the district scale structures, but just looking at where the granites are coming in and some regional maps, I would think there are probably anticlinal zone hinges almost everywhere in the terrain. It looks like every other terrain I've worked on. We want competency and compositional contrast between units and supercrustal sequences. Want some sort of chemical and rheology gradient. So here we've got an iron-rich rock, we've got these flat veins in it, we've got a serpentinite here, and we've got a very felsic porphyry that's got really much iron in it over here. So this is a selective bed. As I understand it, at Sukari, you've got a very rigid intrusion, which has got flat veins in it. That's got a hanging wall of some volcanoclastic rocks, and a footwall of a graphitic shear zone. So it fits exactly the same thing. One rock is failing, all the alteration and mineralisation is going into that rock. It's compressional if you've got the flat veins. It fits perfectly with this sort of model. We just have to find out. Now we've found Sukari, we know that intrusive rocks are good host rocks because, as I said, in this Laverton belt that I worked on, almost every gold deposit was associated with a granite contact with sedimentary rocks or tuffs or something like that. In other belts it's in dolerites. You just have to find the rocks in your particular sequence which are selectively mineralised. So we get a tick here. It fits, Sukari fits very well. We've got to have prominent curvilinear crustal shear zones, lithospheric boundaries, so this is important, or geophysical lineaments. Well, again, I don't know the local geology at Sukari, but certainly when you do a tectonic analysis at a million scale or something, there are great big structures that are trending up there, that are trending about north-south, and there's some big structures that are cutting across east-west. So you've certainly got very large-scale structures that are hundreds of kilometres long based on the aeromagnetic or other information. So it fits very, very well. Jogs in the shear zone. So we want about 10 to 15 degrees in strike variation in major shear zones with an anticline if we've got them. Well, as I see, if we looked at Sukari, just as an example, it looks like the mean trend of the faults. So if we turn north up like this, so the mean trend of the big faults, just looking at the lineaments there, is approximately north-south. So that will make north there instead of there. So that's north. And it's the opposite way around here. It looks like if that's north there, then Sukari is on a jog that tries to trend off to the north-northeast. And the angle, as far as I can see, is about 20 degrees, something like that. I don't know exactly. It looks as if we've got a fault zone that's got gold mineralisation along it. It trends off, it bends around, and it's possibly got a structure across here, although it isn't shown on any of the maps. But I would guess that this bend around is caused by something like that. So it ticks. Cross faults. Well, my suspicion is that the end of Sukari is coming and there's something cutting across it there, although I don't know the geology. It looks like it on the regional map. So we've got some sort of corridors of oblique faults which appear to cut the gold off, but the gold often curves into them and it disappears. It's very hard to find it on the other side. So it seems to control it. So tick again. So something like Sukari is meeting all of the commandments basically. This is something it probably doesn't meet because this is more, you see this when you're in amphibolite facies. Because in green schist you actually cover up the granites. It's probably happening at depth, but you don't know it's happening because you can't actually see the granite. The only way you can see them is through doing gravity surveys over here, and you see a gravity anomaly here and another one there and another one there, as I showed before. If this is where the greenstones are nearly to the bottom of the belt, they're floored by gneisses and granite, and they're amphibolite facies. So I don't know about this. It's interesting that there's a very, very large dome, gneiss dome, out to the west of Sukari. So which seems to be controlling part of the structure, just looking at it. So that doesn't fit so well, but it may fit at depth. We wouldn't expect to see this at Sukari probably because we're too high up in the structural sequence. And then we've got, as a consequence of those